Okay, welcome boys and girls. Let us examine how precise or how accurate our expressions are. I asked a particular boy, Sir, may I know what is your age? The boy would say, Sir, I am 15 years young. Then I will immediately ask him, Sir, are you very sure about the last 5 years? Can it be exactly 15 years or can it be like 15 years 2 months? Or can it be like 14 years 11 months? It means there is a doubt in the last digit. Now I ask a girl, what's your age? She will say, I am 14 years 4 months. Then I will ask her, are you very sure about the 4 months? Can it be like 14 years, 3 months, 25 days? Or can it be like 14 years, 4 months, 8 days? Again there is a doubt. In all our expressions, the last digit appears to be doubtful. Therefore, in an expression, all the digits, including the last doubtful digit, are said to be significant figures. Now, while identifying the significant figures, we can clearly say all non-zero digits are significant. And now, certain zeros are significant, certain zeros are not significant in our expressions. As a first rule, I would say all the zeros preceding first non-zero digit are not significant. Therefore, if I say a number like 0.01, these are not significant, only one is significant. If I say 0.0002, it has only one significant figure because that is preceding the first non-zero digit. Now, the zeros, if I say 500, it is having 2 zeros after first non-zero digit. Even it has one significant figure because zeros preceding a first non-zero digit don't have significance. Zeros followed by a digit without any decimal point also are not significant. Now you yourself can formulate the required rules to identify which zeros are significant, which are not. For example, zeros locked between two non-zero digits are definitely significant. Zeros followed by a decimal point are also significant. Look at this. 19 has two significant figures. 193.8 has four significant figures. 101 have three significant figures. 0.01 has only one significant figure. 500 has only one significant. 500.0 has four significant figures. 0.00018901 has five significant figures. Observing these values, can you formulate rules to identify which are indicating significant figures, which are not? Pause the video, try to formulate, then you compare. First rule is very clear. Second rule, always zeros preceding first non-zero digit are not significant. That is also obvious. Zeros after last non-zero digit where there is no decimal point are non-significant, even that is clear. All other non-zeros before and after decimal point and locked between non-zero digits are significant, even that point is clear. Now, Let us look at the scientific way of writing numbers. In a scientific way, you don't write 560 as 560. You write it as 5.6 into 10 to the power 2. You can also write it as 5.60 into 10 to the power 2. You can also write it as 5.600 into 10 to the power 2. Now, in these three expressions, you will never consider the exponential, this part. You always consider the mantissa to work out the significant figures. Therefore, it has two significant figures and it has three significant figures and it has four significant figures. Right? Sir, if I write it as 0.56 into 10 to the power 3, still it is 560. Now, how many significant figures it has? In that case, it is not a scientific notation. Because a scientific notation should have at least one digit before the decimal point. Therefore, 0.56 into 10 to the power 3 is not a scientific notation. And if you write like that, still if you ask me the significant figures, it has two significant figures. You understood? Can you tell me how many significant figures are there in this expression? 7.8 into 10 to the power minus 3. You are right. It has two significant figures. Now let us examine the last part of this discussion. I will be seeing 1 dozen is equal to 12 items. 1 pair is equal to 2 objects. And a century means 100 years. In all these expressions where you say dozen, that is equal to 12 objects, and I will write here dozen, it has 12 objects, pair 2 objects, century 100 years. In all these there are infinite significant figures because a number locked in a definition has infinite significant figures. Look at this. 3.0 into 10 to the power 4 has two significant figures. 8 into 10 to the power minus 9 has 1. 7.523 into 10 to the power minus 7 has 4 significant figures. So, I hope you got a fair idea about this concept of significant figures. Now, can you write an expression 8012 in such a way that it has one significant figure, two significant figure, three significant figure, four significant figure, five significant figures in scientific notation? I will give an example. If I write it as 8.0120 into 10 to the power 3, it has 1, 2, 3, 4, 5 significant figures. If I write it as 8 into 10 to the power 3 approximately, it has only one significant figure. Now can you show all the variants yourself? I hope you understood, you enjoyed the discussion. God bless you.